Okay, Chapter 9, Section 4, Part 3, Complex Fractions. They are still rational expressions, but a complex fraction is a fraction where the numerator denominator or both contain a fraction. So we have fractions inside of fractions. So examples of a complex expression is here we have fraction bar separating the numerator and the denominator. The denominator has a y. The numerator has a 1 over x. So here our numerator has a fraction in it. The denominator technically does too, because we could put y over 1. Another example, something you might see, is we have just an integer in the numerator, but now we have an expression involving a fraction in the denominator. Okay, these are called complex fractions, and they need to be simplified. You could also see something like fraction x minus 2, that quantity divided by x, subtract 2 divided by quantity x plus 1. So now I have two fractions in the numerator of this outside fraction. The denominator contains 3 over x minus 1. Subtract 1 over x plus 1. Okay, so these are all examples of complex fractions. Now to simplify, multiply by the LCD, which stands for least common denominator, over itself. So we're going to multiply by the LCD, which is your least common denominator, and you're going to multiply by the LCD over itself. Sort of like when we did rationalizing the denominator, you had to multiply by the conjugate over itself. Here we're going to multiply by the least common denominator over itself. So I look in the numerator part of this complex fraction. This thing right here. Now remember, 3 is over 1. So the common denominator for these two items is x. And now I look at the denominator expression and the LCD here just for those is y. But the least common denominator for the whole entire complex fraction is xy. All right, now I'm going to rewrite this . 1 over x plus 3, and I'm going to group it 5 over y plus 4, and I'm going to group that and show that I'm multiplying both the top and the bottom by xy over itself. Now you need to distribute I'm going to take this xy, multiply it with this fraction and this integer, which technically could be written as a fraction as 3 over 1. And then I'm going to take the LCD and multiply it with that fraction and this integer. So what do I get? Well, this is really xy over 1, right? This is not only the numerator of this fraction, but I could put xy over 1, it would be in the numerator. So when I distribute to this, I get xy over x plus 3xy. This fraction bar is this fraction bar. Here I get 5xy over y plus 4xy. Folks, you cannot divide anything out here. This is a sum, and this is division. They're not inverses, so you can't divide out yet. But what we could divide out is this pair of x's and this pair of y's. And the reason we can divide those out is because this is multiplication happening between x and y, and this is division happening with x. Okay, they're inverses, so I can divide those. Equals y plus 3xy, or 3xy plus y. I like to write it that way because I like the x terms first. And then this here would be 4xy plus 5x, or 5x plus 4xy. Now, notice, I could try to factor something out of the numerator and the denominator, but it's not going to help me to simplify. I have a GCF, or greatest common factor, of y up here in the numerator, and I have a GCF of x here in the denominator. So it's not going to help me because the x and the y won't divide each other out. So this is my final answer. Okay. Clearly, if we were looking for restrictions, x and y can't be 0, that's for sure, because they were original variables in the denominators. So that one's an easy one to pick up. Here, I would have to set 4xy plus 5x not equal to 0. Typically with these, we don't do that, at least not in Honors Algebra 2. But if you wanted to at least list the restriction of x and y can't be 0, we could do that. Okay, if you're interested in seeing a restriction there, just ask in class, and I will help you out with that. All right, the next problem. 1 over x divided by y. That was our first example up there. Examples of complex expressions. So I'm going to rewrite this 1 over x and y over 1. The LCD here, well, let's look. Least common denominator, the LCD of this is x. This really is over 1. So LCD, or least common denominator, here is 1. And 1 times x is x. So the least common denominator of the expression is x. So I'm going to multiply by x over itself. I'm going to multiply these two items together, the numerator items. This becomes x over x divided by, and you might want to make this fraction bar a little bit thicker so you can differentiate between the numerator fractions and the denominator fractions inside that fraction. Remember, this is over 1. This gets multiplied by the numerator, so this is xy over 1. Can you simplify within that's still set up to be complex expression. Yes, we can. X over X equals 1. Folks, it doesn't go away. You need to have the 1. And what could I do to simplify this? Well, just divide by 1. So this becomes 1 over xy. And of course, it's pretty simple to see that x can't be 0 and y can't be 0. Okay, so if you have questions, please ask. In class, we have 2 more examples. Example number 3. We got to get the least common denominator. Notice here in the excuse me, if I cover this up just so I see the numerator, least common denominator is 1. If I cover this up, well, this 1 is really 1 over 1. Okay, so this would be a 1y. So the LCD is y. So I'm going to rewrite this. 1 minus 2 over y. LCD is y over y. This is a quantity. The top is just 3y. The bottom, when I distribute, becomes 1 times y is y. Subtract 2y over y. These y's divide out, right? Multiplication and division are inverses. I could divide those out. I can't divide these out, right? Because this belongs in a quantity. So don't make that mistake. The top is 3y. These y's divided out. This becomes y minus 2. And again, that is a quantity. Final answer. Let's see what we got here for restrictions. Well, here, y can't be 0. And here, y can't be 2. So, again, if you have questions, please ask. Now, the next problem is a little bit long, and you have to be organized. So if you're a little bit sloppy with showing the work, you might have an issue. All right. Now remember how you build a least common denominator. It's everything in the first denominator and everything that's different in each successive denominator. So if I look at just this part right here, I need an x and an x plus 1. So I'm building my least common denominator. I need an x times a quantity x plus 1. If I'm looking at this, x minus 1 is not in there. I need it in there. The x plus 1 is already in there. If this was x plus 1 squared, then we would need it in there again, but it's not, so we don't. So now I'm going to copy the problem. X minus 2 over x, subtract 2 over x plus 1. Thick fraction bar, you might want to make it longer as well. 3 over x minus 1, subtract 1 over x plus 1. Multiply by the least common denominator over itself. X plus 1, x minus 1, x plus 1, x minus 1. And now you have to distribute. All right. Guess we'll just write it all out. So I've got this times this times this times this. So let's do x times x plus 1 times x minus 1 times x minus 2. over x. Subtract. I'm going to put the 2 first. I know I didn't do that with the x minus 2, but it's all right. I didn't do that because it was a quantity and I didn't want this x sandwiched in between. So this 2 is that 2, and then I'm going to copy this. Over x plus 1. Remember, this is a quantity. All right, now I've got my thick, longer fraction bar. So again, this isn't difficult, but it does take a little bit of time, and if you're in a rush, you're going to make silly mistakes. 3 times these 3 items. Over x minus 1. Subtract. 1 times that is just that. Over x plus 1. Now at this step, this is where we're going to divide stuff out. And that's why we multiply by the LCD over itself. Okay, back up here. We multiply by this so that it eliminates all of these denominators. So we could get this to be a non-complex expression. These x's will divide out. This quantity x plus 1 will divide out. This x minus 1 divides out. And this x plus 1 divides out. So what do we got when we simplify this? Well, we've got x plus 1, x minus 1. X minus 2, subtract 2x times x minus 1. Now notice these denominators went away. They're 1s now. So this fraction bar, the longer, thicker one, is this fraction bar. See? So this is becoming less complex, if you will. Now we're not done because you do have to simplify this. All right? Let's look at what's in the bottom first. 3x times x plus 1. All right, these are gone. So I'm just copying what's not crossed out. Subtract x times x minus 1. We have to simplify this. You could, to save one step at least, x plus 1 times x minus 1, when I multiply those, that gives me x squared minus 1, because those are conjugates. All right, so now I'm going to FOIL. You have to FOIL. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. This here gets distributed into that grouping. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is positive 2x. The denominator, 3x times x is 3x squared. 3x times 1 is plus 3x. Negative x times x is negative x squared. Negative x times negative 1 is positive x. Now you have to look to see if we can combine any like terms. Well, I have 2 quadratic terms here, and I have 2 linears. So yes, I have to combine that. So x cubed does not get combined. Negative 2x squared, negative 2x squared is negative 4x squared. I like to lightly cross them off so I know I'm combining everything. Negative x plus 2x is plus 1x plus 2. All right, the bottom. I've got 2 quadratic terms. 3x squared minus 2x squared. 3x squared minus 1x squared is 2x squared. Okay, I'm not crossing these off because they divide out. I'm crossing them off because I'm combining them. 3x plus 1x is plus 4x. Now, we really should look at this to see if we could factor and divide out any common factors. The top, the only thing we could do there is factor by grouping. I don't think we're going to be able to factor anything by grouping there. If I put these two together and take out an x squared, I'm left with an x minus 4, and that's not x minus 4. So I think no matter how you rearrange those, you're not going to be able to get a common binomial factor. The denominator, I could take out a 2x, but is that going to help me with dividing anything out of here? And the answer is no, because 2x is not a GCF of that numerator polynomial. So this is my final answer. Again, unless it tells you to list restrictions, I wouldn't, well, I shouldn't say you don't have to list the restrictions because it's always part of the answer. We'll at least list the small ones. X cannot equal, if I just go back up into the original problem, x can't equal 0. It can't equal -1. It can't equal +1. And here -1 again. So definitely 0, -1, and +1 for sure. This one here, we're not going to get a restriction. If I take an x value, no matter if it's positive or negative, and I square it, this number is going to be positive, and then multiplied by 2 is going to be much bigger than this number. Okay, even if your negative gets smaller and smaller, you know, like -8. Well, -8 squared is 64 times 2 is 128. 4 times -8 is not bigger than that. So we don't have any restrictions here. Okay, so let me know if you have any questions. You can ask in class or post on the homework discussion. And let's see what you can do with the assignment. Have a great day.